Hello.
It's a directional mic.
Is it on?
Random strangers.
It's on.
Liam, they can probably hear you with the microphone.
Maybe. Did I tell you last time I turned it up, plugged it in, I forgot to turn the microphone on?
Yes.
So
Yeah,
it's
but
just
I mean,
sitting there on top.
And
Did you turn it on?
This time I've turned it on, yes.
Can it not hear me at all?
I don't think it cannot hear you at
Are
all.
you sure?
I don't know, we'll test it.
Can it hear
No.
you?
I don't know.
No, because that's...
Instagram.
No,
Directional
it's not. What
microphones
if
are
my
rather
sound is
directional, so I would assume that it's somewhere up here. It might pick up a blur in the background.
Would you like us to talk loud?
Anyway, back to the
Maybe.
discriminant. What if it's
Anyways,
backwards? What
Shivani
if
wants
it's
to move on. That's the discriminant. This is highly relevant though, Shivani. It's a parabolic mic, alright? So, discriminant is just this small portion of the quadratic formula. Alright? I think I've told some classes before, do you know what discriminant means?
To discriminate.
Yeah, what does that mean?
To separate.
Yeah. To separate or to choose. So discriminate by itself is not a bad word, it's a negative connotation we have because it separates peoples into subgroups. This separates the quadratic formula into three different scenarios. Alright? So you can have the discriminant where it's less than 0, which gives you no solutions, unless you're in specialist, in which case you can get to make up some numbers. Right? Less than 0, so at this point here, if you've done your maths right, you'll see a negative number. Obviously we can't square root a negative number, so you stop and you say there are no solutions. Right? Fairly straightforward. The discriminant could be equal to 0. In which case, what's the square root of 0? 0, so plus or minus 0 changes nothing, and that means there's one solution, because you're adding 0 or subtracting 0. One solution, alright? Or it could be greater than 0, in which case there are two solutions, the positive version and the negative version, and you have yourself two x-intercepts. Alright? If you've done your maths right, it's perfectly valid to get no solutions. Okay? Often we're used to going through the whole process and getting to the end and being able to simplify all the way down to an answer. Often with this you'll get to a point where you go, hold on a second, it doesn't make any sense. You may have made a mistake, or it might be legitimately the fact that there are no solutions for the graph. Right? Not every parabola goes through the x-axis, as you can see. Okay? So if you've done your maths right, don't be afraid by this one. Alright? Any questions? Okay, I'm going to erase these. So there are a few different types of questions that you will deal with.
In the textbook or just in general?
In the textbook and in general. Alright, first one, most straightforward, is just one where they give you a parabola minus 6x plus 8.
Is this for number 1 or is this separate?
This is just an example. I'm leaving those up here so that we can see which of the three cases we have come across. Alright, so the first one they'll just say, what's the discriminant worth? Alright, and then possibly interpret it into how many solutions there are. So you want to go A equals 1, B equals minus 6, and C equals 8, and then sub it into the discriminant. Four eights are 32. 4. The discriminant is worth 4. Which case is that?
That is 3.
Right, 3. So what does that mean?
There's 2 intercepts.
2 x-intercepts. Right, so the first type of question is interpreting what the discriminant means. Does that make sense?
Yeah.
Good. Do you want to do another one yourselves? Yeah, it doesn't look too hard, does it? 2x
Until you
squared
give us
minus 3x plus 4.
something like that.
Right, A, B and C, go. Write it down in your books. A equals 2, B equals minus 3, C equals 4. Discriminant is this. So it should look something like this. Is that what everyone's got?
Mm.
Yeah? 9 minus
32.
32.
Yeah.
What does that mean?
Negative 23.
What does that mean?
No.
No solutions. Right? The discriminant is less than 0, which means there are no solutions. Okay? Yeah? Alright, what about x squared minus 8x plus 16? A, B, C?
Discriminant equals 0.
Equals 0. 4, 6, 24. How many solutions?
1.
1. How do we know?
Because it equals 0.
It equals 0. Good work. Equals 0. Right? One thing you might come across is that they substitute this out for delta.
Okay.
So that equation just means the triangle as well.
Yeah, it's a symbol to show the equation.
That's what you do.
Is it always that? So whenever a triangle is shown, it's always representing that?
No.
It's not?
If maths was that easy, it'd be no fun.
It means something similar, but it doesn't always mean the discriminant.
Yeah, sometimes
Well,
it
that's
means...
bullshit.
In calculus, it just means change.
Mm.
In algebra, it means the discriminant. In
So
chemistry, it
what's
means
the point of
change.
showing us the triangle if it's not
So the
always...
similarity is that this means the change. This is the thing you look at, the change maker, is this. Because if this is less than 0, then that runs the entire equation, or equal to 0, or greater than 0.
okay.
So it's sort of a similar idea, but not strictly the same.
So would you say delta is equal to 2?
If you would write it as delta is less than 0, or delta is equal to 0, or delta is greater than 0, then you say therefore 1 solution, 2 solutions, or 0 solutions.
So that just means you don't have to write the whole equation.
You don't have to write this, or the word discriminant. Yeah. Alright, so, first type of question. Just a straightforward analysis of the discriminant and interpreting what its result means for the graph. Alright? Pretty straightforward. The reason it's not necessarily faster than just using the quadratic formula from the start, right? Because if you reach this point, you've still got to write the quadratic formula and substitute that in for the discriminant. So I don't care if you start by writing the quadratic formula and then stopping when you reach a point like this underneath the third sign, all right? And interpreting the result after that. Because the discriminant is less than 0, therefore there is no solutions, okay? When you see a question like this, though, they might phrase it and say, using the discriminant, decide how many solutions there are, in which case you would just go straight to using it. You wouldn't have to write the quadratic formula. But if you're just solving a quadratic from scratch and you're not quite sure how many solutions there are, and you can't be bothered going to the discriminant in case you find a point where there are actually 2 solutions and you have to rewrite the quadratic formula anyway, then just go straight to it, the quadratic formula.
You wouldn't have to.
You just sub in the form.
Yeah, you just sub it in.
Yeah.
But you're still going to have to write it at some point if you have 2 solutions or 1 solution.
So if the question just asks find the discriminant of this,
Yep, just do that. Or if they say, using the discriminant, decide how many solutions there are, you just go straight to the discriminant. But if they say, solve this quadratic,
So how would you sub the answer into the quadratic formula?
so this one that was 4, you would just go minus b plus or minus root 4
Oh,
over 2a.
okay. So it's
Which is
minus b plus or minus 2 over 2a.
Yeah.
which
Okay.
then just ends up being whatever.
Yeah, that's right. So you can just sub it straight into that point there, but for me, I don't notice it's necessarily faster finding the discriminant first and then subbing it in.
You just do it all.
Because you have to then sub that in, you can just do it all at once and then stop whether or not that tells you to stop or not. Alright? Okay, second type of question is a little bit different and maybe a bit tricky for some people. Alright? This is where you're going to be given a quadratic formula that has a variable inside the b value. Right? Straight off the top of your head, the discriminant tells you to square b. What's going to happen to m?
Squared as well.
Squared. So it's going to become its own quadratic inside a quadratic.
Well, that's
Right?
stupid.
So, a equals 3, b equals 2m, and c equals 3. Right? Don't forget that the coefficient of x is everything that is not x. So it's 2m. So, subbing it in looks like this. 2m squared minus 4, 3, 3. Yeah? 4m squared minus 36. Right. What do we actually know about it?
It's stupid.
Can we read anything out of it?
No,
What does it depend on?
the M.
M.
So we don't
It all
know.
depends on what m is.
We have to work out what it is.
So we're going to work out what m is
Oh.
Solving it.
by solving it. Right?
You put
We're going to solve it for one of these three cases. So, for this whole thing to be less than 0, we need to know what m is, don't we? Because you can see that 4 times 9 would equal 36, and 36 minus 36 is 0. So if that's underneath 3, roughly, we're going to get some values, and if it's over 3, it's going to be something else, isn't it? Alright, so we're going to take it, and we're going to set it equal to 0. Alright, we're going to solve it for where m is equal to 0. So how do we do this? We could divide at this point. We could also move the 36 across. Then divide, then square root. What does that mean?
M is equal to 3.
Or negative 3.
Or negative 3. And what do those numbers produce? How many solutions do they produce?
3. Wait. Yeah, no.
2, 0, 4, 1.
No. 1.
No? So m, if m equals
1 or 0.
positive 3 or m equals negative 3,
Well, in either way, they would all equal out to 0.
It,
So
this,
it's one solution.
one solution. Good. And how do we know that from the original red line that I wrote there?
Because it equals 0.
Because it equals 0. I solved the discriminant for where it equaled 0, which was one solution, wasn't it? So the answers to that produce one solution. Alright? The answers to that produce one solution. So,
Is that in any equation that you, whenever there is a variable there,
in
and
B,
you do it, yeah, and you solve it when it's equal to 0, then it's always going to be.
because you have to remember you're solving the discriminant for where it equals 0.
Yeah.
Yeah? So if you solve the discriminant for where it equals 0, it spits out one solution.
If we solved it for if it was less than 0, more than 0.
There we go. Alright, and this is where that previous set on inequalities comes into it. Can we solve this for where it's less than 0? How do we do this? What do we do?
You change the end value?
Well, what, is that something we did in the set?
No.
I don't know.
How do we solve this inequality for where it's less than 0?
You need to factorize it.
Factorise it? What's that going to produce?
Pain.
Wait, so we have to test it with all.
What the?
Yeah. Because you have to
Is
get
that any new information?
No.
No. All it's telling us is that the x-intercepts are at -3 and +3, isn't it? So what did I ask you to do every time you solved an inequality?
But there's going to be no
Make it equal
solutions.
0.
so it's less than
No.
0.
I asked you to sketch, didn't I?
Oh.
Yes. Thank you for your remembrance. Is it a positive quadratic?
Yeah.
Yes.
But the y-intercept is plus 3.
The y-intercept is
Positive
3.
correct me if I'm wrong, I think the y-intercept is minus 36.
Yep, I agree.
Yeah?
Wait,
y.
This one here. We're solving the discriminant. We're not solving the original. We're solving the discriminant. Alright, this is what I mean. It's a quadratic inside a quadratic. At this point, we ignore this now. All I'm interested in is the m value.
I don't like
So
that.
we went from solving the
No, no,
first
no, no.
one into not giving
No,
a
we
shit
went from
about it.
evaluating the discriminant, not solving.
Okay.
We are evaluating the discriminant here. Now we are deciding what m values are relevant. That has nothing to do with this.
Wait, are we doing testing that solution?
We're trying to work out which m values produce less than 0,
Why do you
equal
hate
to
us?
0, or greater than 0. Alright? We don't know the m value, so we have to treat it like a quadratic because it is one.
Great.
So we're
Alright.
gonna have like 3 different.
You're not going to have 3, you'll have 2.
Great.
Alright? So, this quadratic here, the red one, we're going to solve it. We'll just graph it. Minus 36. There it is there. Quite straightforward. It equals 0 at that point and that point, which we already knew. M equals 0 at positive 3 or negative 3. Right? Just there.
Wait,
But
how
then
did
that's-
you
That's 2 solutions.
That's what I said.
Children, he's not done.
That's a good point. What's the square root of the square of negative 3?
Positive.
There
is no square root.
If I substitute negative 3 into there, what's the answer to the discriminant?
0.
If I substitute positive 3 into there, what's the answer to the
0.
discriminant? 0. So even though there are 2 solutions that produce 0,
How is that
what that will mean is when I put that discriminant back into the quadratic, the discriminant is still going to be 0. Remember how this is not relevant to this one here. All I'm interested in is the m values. Alright?
This is torture.
There's like
Wait,
4
sorry.
different sets of rules.
No, it's not. It's the same set of rules. We just have to ignore this for now. Once we've found the discriminant, we say, I'm not interested in this one anymore. I'm now interested in this quadratic.
I can't wait till I overcomplicate it.
Alright? So, to find where it's less than 0, where is that?
Anyway,
in between
in
negative
between
3.
there.
This area here.
Mm.
So for the discriminant to be less than 0, m has to be
Great.
between negative 3 and positive 3, doesn't it?
Yeah.
Yep. Where is it greater than 0?
Outside. Less than negative 3.
Out here and out here. So for the discriminant to be greater than 0, m has to be
Less.
minus 3 is less than m. No, other way around. Or m has to be bigger than 3, doesn't it?
Yes.
Yeah.
Yep. Okay, now let's test it out. We've already tested it for these 2 solutions. We know that minus 3 squared is positive 9. Positive 9 times 4 is 36, and 36 minus 36 is 0. Alright? A number inside this region here. Let's just take positive 1. Alright, so 4, 1 squared minus 36. Is that going to be bigger than that?
Hold on. I can't see
No.
before.
4 minus 36 is negative 32.
Wait, what are we
If the
doing?
discriminant is negative, that means there are no solutions. So in here, these are m values, there are no solutions because the discriminant is worth negative numbers. Follow the red line. Is the red line less than 0?
Yeah.
Yes. The red line is showing us a graph of the discriminant. If it's less than 0, that means that the discriminant is less than 0, which means that when you put it back into the quadratic formula, you end up with no solutions. Alright?
Wait, what?
I'm not getting it.
Where did you get the 1 from?
I just chose a random value from inside this region.
Oh.
Inside that region. Alright?
Oh, no solutions is in like.
No solutions is in between the x-intercepts of the quadratic. It's a nested quadratic inside a quadratic, and it's not relevant to this
Will
anymore.
we have
Oh, I get
questions
it.
like this?
100% yes.
Fucking hell.
What about when the discriminant is greater than
And I
0,
thought I was starting to
are there no
understand.
solutions or are there solutions?
So when the discriminant is greater than 0, what happens when the discriminant is greater than 0?
Two solutions.
2 solutions.
But how? How?
2 solutions? Because the discriminant produces a positive result, yes? Yeah? So,
That's a different problem to the first one.
yeah. This is a different graph to the first one. It has no relation to this at all, right? Other than the fact we've used A, B and C to create it. Alright, so take a value from outside here or outside here. What would you like to use? Less than -3 or greater than +3? Which one? 5 or 4? Let's go 4. Alright, so 4 is up here somewhere. 4. So I'm plugging that as an M value into the discriminant. Alright? Into here. So 4 bracket 4 squared minus 36. What's 4 squared?
16.
So 4 times 16 minus 36. What's 4 times 16? 64 minus 36. Do I have to go any further? Is that going to be positive or negative?
Positive.
Positive. The discriminant is positive at that point. What does a positive discriminant mean? 2 solutions. Right? This graph is a graph of M, not a graph of X.
Oh.
Right? Because what we're concerned with is, this is the discriminant, but I don't know what M should be. I know that these 3 cases have to be true, but I don't know what M should be. At the very minimum, you're going to be sitting there plugging values in to work it out.
So those shaded bits are what M could be.
That's right.
Oh.
Right?
Okay.
We are interested in, how do I make the discriminant less than 0, equal to 0, or greater than 0? But because there's a variable there, I don't know what to do. Because I could just plug M values in, couldn't I? That's how people solved inequalities before we learned how to do it. Randomly plug them in. You'd be there forever if you chose the wrong values to start with. Right? So a shortcut is, treat it like an inequality. Sketch this quadratic. Find where it equals 0. At that point, you've got 1 solution. Right? I know it seems like there are 4 solutions now, but you're dealing with the M values, which get put back into the discriminant, which get put back into the quadratic formula.
Huh.
Alright? Once you've found those equal to zeros, sketch the regions that give you the other 2 scenarios, less than 0 and greater than 0, and express them as inequalities. Alright? A question like this will be phrased, it'll say, given this quadratic, find the values for M such that there is no solutions, 1 solution, and 2 solutions. Alright, it will say it like that.
And I'm gonna fail that.
Sad.
Clues you'll be looking for are if there's a variable in B. If there's a variable in B, you've got to do some extra work. Alright, it's not as straightforward as just evaluating the discriminant. Second clue is, you'll reach this point here and you go, I can't read anything out of it. I can't tell what it has to be. Alright? So if you see the variable, or if you reach this point and you go, I don't know what to do anymore because there's a variable there, you're going to have to keep going. And sketch the graph, solve it for where it equals 0, that's 1 solution, and then express the other 2 as inequalities. Right? It is hugely valuable to sketch this graph and shade the regions, because otherwise we lose it. Alright? Let's try another one. Here. You want to leave that one there?
Yes.
What are we supposed to use instead?
Bring that board up.
The one.
What?
Permanent marker.
Is that permanent marker?
Mm-hmm.
The black.
Who that? Definitely you. Is there anything on the back?
No.
Other than some markings.
That's my stuff. Alright.
There's so many whiteboards in this room.
Yeah, I don't know how they got the ball. Right, here is your quadratic. It's one of the problems from the set. X squared minus 4mx plus 2 equals 0. x squared minus 4mx plus, no, wait, no mistake, plus 20. There we go.
Is equal to 0.
Yep. All you're doing is finding the values of for m for which there is no solutions, one solution, and two solutions.
Can you add the question?
Yep. So it says find m such that there is one solution, two solutions, or no solutions. So your first step is to find the discriminant. B squared minus 4ac.
Oh.
Discriminant first. So you should have gotten A equals 1, B equals minus 4m, and C equals 20.
Yes, I got that.
Sub it into B squared.
Percent I got that.
You got Z.
I really don't.
Yeah, no, that's that undefined variable. Calculates work off x and y.
Oh, so I have to type in X.
Yeah, you have to use x.
Alright.
Get that.
What is this?
Oh, appreciate it. Yeah, you want to see that split?
So now you want to interpret the different scenarios. Case 1, case 2, case 3.
And this is plus or minus which?
Oh.
Yep. So those are the points at which it equals 0. So that those two will give you one solution.
It does go into
So then what about two solutions or no solutions? And remember, David, those are the most important parts. Now I just do a quick sketch
So it's about
and shade those regions.
Yeah, I know, wrapping it. It'll be about
No one cares. It's just root 5.
I don't even know where root 5 is, so I just go root 5.
That's all you've got to do.
Yeah.
Right, so b squared should be minus 16m squared minus 4 by 20.
Why is it
By
minus
one?
16 to b squared?
Yeah. The one, 16m squared minus 80. Does that sound right?
Yes.
Good. So everyone solved it for where it equals 0. So it becomes 16m squared equals 80. M squared equals, what's it? 5? Good work, everyone. M equals plus or minus root 5. Okay, so, translating to your answers. They solved it for where it equaled 0, which means, how many solutions? 1. So up here, you would write down M equals plus or minus root 5. One solution is where those two values are M. Then, to find the other two, we're going to do a quick sketch. You don't have to know what root 5 is worth because no one cares. All you have to know is it looks something like this.
So this is not actually important to sketch an accurate graph.
No, at this point all I'm concerned about is getting the regions right. Alright, in here is where it's less than 0, yes?
Yeah.
Out here is where it's greater than 0. So then write them as inequalities. So for two solutions, which region am I looking for?
The outside.
The outside. So I would say that m is less than negative root 5 or m is greater than positive root 5. For no solutions, that's the inside area where the parabola is less than 0. So I would be saying that negative root 5 is less than m, which is less than positive root 5. Alright? The important part there is getting the regions translated into an inequality, and I'll do them in different colours. Is it starting to make a bit more sense now that you've tried one?
Yeah.
Yeah? I know it was confusing at first to see a second quadratic pop out and be really strange.
So with the y-intercept of that be negative 8?
Yeah. So this is what you're graphing. Does anyone know what form that's in?
Difference between the squares.
Yeah, what does that tell us though? No? Yeah, and what transformation has occurred in this thing?
It's down 10.
It's moved down 80
With the dilation.
with a dilation factor of 16. There's no horizontal, is there?
No.
So the turning point is directly, or it should be, directly on the y-axis. It's just moved down. That's the only transformation that's happened. Right? Can you think of any scenarios where the discriminant might be different from that?
Wait,
If you have a variable for A or C.
Yeah, if you had a variable for A or C, or if you had a binomial in here that, like, instead of just being a straight 4m, it might be m minus 2. It'll start to look different. Right? But if it's just a straight variable, it will look like this, and you can just